Let's look at proposition number 13 and 14 of works of Archimedes, specifically from on conoids and spheroids. The proposition says, if a hyperboloid of revolution be cut by a plane meeting all the generators of the enveloping cone, or if an oblong spheroid be cut by a plane not perpendicular to the axis, and if a plane through the axis intersects the cutting plane at right angles in a straight line on which the hyperboloid or spheroid intercepts a length r prime, then the section by the cutting plane will be an ellipse whose major axis is r prime. Quite a mouthful. So let's break it down and understand what is happening here. I think it's clear that he is talking of two separate figures. One is the hyperboloid of revolution and the other is a oblong spheroid. So hyperboloid is proposition 13 and proposition 14 is the oblong spheroid. Proof is more or less the same. So that's why he is combining these two. Now, the proposition is saying, let's cut this plane meeting all the generators of one part of the hyperboloid. Let's take one of the generators. Then there are 2 points r prime. When we join them, this would be the major axis of the section of the hyperboloid by the cutting plane, and this section would be an ellipse, is what the proposition is saying. So let's take it step by step. Given a hyperboloid of revolution with its axis passing through the vertex A, let a plane cut the hyperboloid meeting all the generators of the enveloping cone perpendicular to the plane of the paper at an angle. Let another plane cut the hyperboloid through the axis, intersect the cutting plane at right angle in a straight line on which the hyperboloid intercepts a length r prime. So how we got this r prime is by having another plane which is perpendicular to the cutting plane and passes through the axis. So these two planes will intersect each other in a line, and the part that is intercepted by the hyperboloid is r prime, and that is the major axis of the ellipse, which will be the section of the hyperboloid by the cutting plane. Now let Q be a point on the section made by the cutting plane. So let's mark the section made by the cutting plane. Now let's Q be a point on this section. Let's draw QM perpendicular to r prime. Through M, draw DFE, a straight line perpendicular to the axis, meeting the hyperbola at D and E and the axis at F. F is the intersection of DE with the axis. Now draw a tangent PT parallel to r prime and a tangent at A intersecting PT at O. T is the intersection of the tangent with the axis and a tangent at A. Now we draw PN perpendicular to the axis intersecting it at N. Now QM square is equal to DM times ME. How can we say that? Now if we draw a plane passing through DE and QM, then this plane will cut the hyperboloid in a circle. Semicircle DQE is on DE and QM is perpendicular to DE. QM square is equal to DM times ME. So DM times ME is to Rm times Mr prime is equal to AO square is to OP square. This is from one of our previous propositions. Dm times Me is Qm square. So Qm square is to Rm times Mr prime is equal to AO square is to OP square. Now here, this is a hyperbola, which means that AT is less than AN, which in turn means OA is less than OP through similarity of triangles. OT is less than OP and OA is less than OP. Because of this proportionality, since AO square is less than OP square, we can say QM square is less than Rm times Mr prime, which means the locus of Q is an ellipse whose major axis is R prime. Let's take the case of the spheroid. So given an oblong spheroid with the axis given and A as a vertex. Let a plane cut the oblong spheroid not perpendicular to the axis. Let another plane cut the oblong spheroid through the axis, intersect the cutting plane at right angle in a straight line on which the oblong spheroid intercepts a length R prime. So let another plane cut the spheroid perpendicular to the cutting plane. And here you will notice that the spheroid intercepts the intersection of these two planes. And let's mark this as R prime. Now what the proposition is saying is that this would be the major axis of the ellipse that is cut by the cutting plane. So just for reference, let's take this as one of the generators of the spheroid, and let this be the section of the spheroid cut by the cutting plane. Let Q be a point on the section. Draw QM perpendicular to R prime. 2M, draw DFE perpendicular to the axis, meeting the spheroid at D and E and the axis at F. So let's draw that. Now the intersection of this DE with the axis is F. Let KK prime be the diameter passing through the center C parallel to RR prime and BB prime be the minor axis. Now draw a tangent PT parallel to RR prime and a tangent at A intersecting PT at O. And again we take a tangent at A intersecting PT at O. Draw PN perpendicular to the axis, intersecting it at N. Again, as usual, QM square is equal to DM times ME. How? Because again, if you remember, if we draw a plane through DE and QM, the intersection of that plane with the spheroid will be a circle. So which means we will have a semicircle DQE and QM perpendicular to DE, so that QM square is equal to DM times ME. DM times ME is to RM times MR prime is equal to AO square is to OP square. This is one of our previous propositions. Now DM times ME is QM square, so we can say QM square is to RM times MR prime is equal to AO square is to OP square. Remember this minor axis and the diameter of the spheroid KK prime. Now BC times CB prime is to KC times CK prime is equal to OA square is to OP square. Since KK prime is the diameter parallel to RR prime and BB prime the minor axis, which means OA square is less than OP square. Why? Because BC times CB prime is less than KC times CK prime. Very clear? Now since OA square is less than OP square, that means because of this proportionality, we can say QM square is less than RM times MR prime, which tells us that the locus of Q is an ellipse whose major axis is R prime. So that was proposition number 13 and 14 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.